Hello General Maths students. In this video we're going to look at compound interest. In previous videos we've been using the simple interest formula to calculate an interest amount. That's fine when there's a single amount being added on to an investment or a loan, so a single amount of interest being calculated at the end of an investment or a loan. But in compounding interest, what we find is that interest is added throughout the investment or the loan. So every period within that investment there's an amount of interest being accrued, and that has the effect of adding interest to the original amount, but also adding interest on top of the interest. So it's a bit different. So let's look at the formula. This is it here. So we can see that it's an exponential formula because we have this power of n here. So it's a non-linear formula. Now the FV, that represents the future value. So that's the amount in the account at the end. Now it's worth noting the difference there with simple interest, how we calculate the amount of interest at the end of an investment. And if we want to know the total amount, we've got to add that onto the principal. But with this future value, FV, that gives us the total with interest and the original amount together, which the original amount is the present value, PV, so that's how much is put in at the start of the investment or loan. Now, instead of an R for the interest rate, we have a lowercase I, and that's an interest rate per period, which is a bit different. We need to adjust that interest rate per period. So as you can see here, 8% per annum. If that's quarterly, well, we divide that by 4. 8 divided by 4 gives us 2% per quarter. So 8 divided 4 gives us this 2. And the reason we're dividing by 4 in that case is because it's a quarterly rate. Depends on how many interest-bearing periods there are per year. That's the number we divide by. And we've got a couple of examples below which are different, one that's quarterly and one that's monthly. So we'll be able to see how we adjust that interest rate in those examples. So the number of periods n, that's kind of like our time. So in the simple interest formula we had time in years, a capital T, but in this case we measure time by the number of interest-bearing periods, not the number of years, and that's that n value. So let's jump into the example here. $5,000 is invested at 9% per annum, added quarterly. How much is in the account after 8 years? I'm going to write down the variables here. FV, PV, I, and N. Now, you might want to pause the video at this stage and see if you can write down the values of some of these variables. It's a bit. Some of these are probably pretty manageable, especially if you've seen compounding interest before, but some might be quite new to you. So pause the video and give it a go, then I'll try. Okay, so I'm going to have a go at it now. Right, so the future value we don't know. I'm going to put a question mark there because we're trying to calculate the future value. How much is in the account after 8 years? The present value, PV, is our 5,000. So that comes from this one here, the $5,000 is our present value. Now the I value. So to get that, we're going to look at this interest rate here, 9% per annum. And it's important that it's compounding quarterly. That's the number, well, that tells us what number we need to divide by. So just like simple interest, we need to convert this rate to a decimal. So to do that, we divide by 100. So 9 over 100 gives us 0.09. Now, if you got that far, that's pretty good. So I'm going to take that 0.09 and write it over here. Now, we're not finished yet with that because quarterly is 4 times per year. All right? So that means we need to divide by 4 because there's 4 quarters in a year. Just like there's 4 quarters in a football match, there's 4 quarters in a year. So we go 0.09 and we divide that by 4. Now we could work that out. In fact, I will, but I usually don't worry about doing this. But I'm going to do it now just to demonstrate something. So there's 0.09 divide 4 is 0.0225 per quarter. Righto. Okay, so we'll leave that there for now, and I'll show you some stuff with the calculation for that later. Okay, number of interest-bearing periods. Okay, so we're thinking time here. So we've got the time in years over here. 8 years. Oh. Just trying to highlight that. 8 years there. Right, and this is once again 4 times each year. So like the football match analogy, if you played 8 football matches and there's 4 quarters in each match, then how many quarters have you played altogether in 8 football matches? Well, we multiply the 2. So in this case, it's 8 years by 4 times per year gives us 32 interest-bearing periods. So our end value is 32. So we go now and we put those all into the equation. So FV equals, okay, PV is 5,000, bracket 1 plus. Now, I like to just use the interest rate as a fraction, so the decimal over over the number of periods, rather than writing down the rounded off value, because sometimes these divisions, you can imagine they don't round off very nicely, and you've got to cut them off somewhere. So you're not quite getting the exact answer. So I like to just leave it as a fraction, because the calculators we use in this course will let us put that in really easily. So I'm going to leave it like that rather than putting 0.0225. But if your teacher or whoever's showing you how to do these does do rounding off, or you prefer to do that way, that's how you've learnt, that's fine too. That'll work fine. All right, and then to the power of 32. Okay, so just a bit more colour coding so we can see where everything's come from. And the interest rate came from the purple bit, and then our present value is the 5,000 there. Okay, so we'll pop this into the calculator like this. So if you're using a scientific calculator like this one, which I think is a good choice in this situation, we use this button here to get that fraction. A TI Inspire or a Casio ClassPad 400, as we're using at the moment in these courses here in Tasmania, will work fine too. They can do all this stuff. Okay, I'll close the bracket, and then my power of button here, the power of 32, equals $10,190, and now we're going to round to the nearest cent here, so it's 52 cents to the nearest cent. Okay, so that is our final answer. 10,190 and 52 cents is the final answer. All right, because we're asked how much is in the account after 8 years. That's the total. So this here includes the $5,000 principal and the interest on top of that. Righto, now we've got another question here. Now, after you've seen this example above, you might have an inkling that you could try this one on your own before watching what I do, because you've seen the mechanisms of this type of question, or how to use this formula. So go ahead and pause the video now, if you like, and try this question, and then I'll have a go at it afterwards. Okay, I'm going to try this question now. So I'm just going to go straight through it, assuming that you've had a chance to have a go at it, but pause at any time, of course, and try it on your own. Right, so future value, present value, I and N. Right, so the future value in this case, we're trying to find. So we're asked to find the total amount of interest. That's a little different. Just watch out for that one, because they're asking us to find the total amount of interest, right? So just be careful of that. That's a little bit different. Anyway, we'll cross that bridge when we come to it. $650 is invested, so our present value is $650. Okay, now the interest, we've got our 4.8%, which we convert to a decimal, so 0.048, and this time it's compounding monthly. So how many months in a year? Well, there's 12 months in a year, so we need to divide this 0.048 into 12 equal parts. So we just divide it by 12, right? And that probably rounds off quite nicely looking at that, but I'm just going to leave it as that fraction to put into the calculator like that. All right, number of periods. Okay, so we're going at 5 years, 12 times per year, so 5 by 12, which is 60 periods. So there are the values that we put into the equation. Now, if you didn't get that far first time around, maybe you want to pause the video and try putting that into the equation now, then I'll do it. Okay, so let's see. Final value equals our present value 650, bracket 1 plus 0.048 over 12 to the power of 60. So that's what we're going to put into the calculator. So that'll look like this. $650 bracket 1 plus, get the fraction button happening, 8 over 12 to the power of 60, which gives us 8.25 and 92 cents. 8.25.92. Okay, now remember that we've been asked to find the amount of interest, and this 825.92 represents the total amount of interest. The total amount interest and the original principal, or the present value rather. Okay, so we need to subtract the 650, the original or the present value, from that. All right, so interest is equal to 825.92 minus 650. So if I just go back here and take 650 off that answer, that'll tell us that the amount of interest is actually $175.92. So that is in fact the final answer for this one, because we're asked to find the total amount of interest. So thanks for watching. Go ahead and check the questions in the description for the video and try some more compound interest questions.